Hey guys, it's Mr. Honda. I know we just did this lesson the other day, but I just kind of figured between doing the lesson one day and then doing the assignment today, some of you might need a refresher. So this video is just to get you started. So go ahead, have some paper ready. This is not notes. This is us actually starting the assignment together, and this is specifically number 9 off your assignment. Okay, so what we were talking about the other day was this idea of point-slope form, that it's just yet another way to take information about a linear equation and to come up with the actual equation itself in a format called point-slope form. Okay, so we've got our point and we've got our slope, which makes this ideal for point-slope form. And the instructions say in the book, write in point-slope form an equation of a line that passes through the given point and has the given slope. Okay, so just a reminder, here's how you do it. This one, again, pretty easy because since our information matches the format, all we really have to do is plug stuff in. And once again, you can check your notes, but if you don't want to, again, here's the format for point-slope form. Y minus y1, where y1 is going to be one of the pieces of info we stick in, equals m, the slope, which again, there's going to be a number that's going to be input there, and then x1, which is also information that's going to be input. Okay, and it's just a matter of understanding what's what. This xy pair is going to be x1 and y1. This is the slope. And so what we do is y minus y1, which is the negative 5. Okay, equals slope, which is m, which is the negative 1/7. X minus, and then x1 is the 7. Okay, just plugging in the right information into the right locations. Now again, the book said write your equation in point-slope form, which this already is, so other than just a little bit of cleanup like this minus and negative, let's change it to plus. You can leave it like this, okay? Even though it seems like it'd be cleaner if we did distributive property here and moved a few things around, that this is what we consider point-slope form, so we're just going to leave it like that. And this should match what's in the answer key. All right. Now, I want to do one more with you to get you going because, again, what we discussed in class was there was 2 different types of problems, and the other one's a little bit trickier because it doesn't fit as nicely as this one. This one, they gave us a point and they gave us a slope, which was perfect for point-slope form, but for this problem, a little bit different. So I'm going to do number 14. So number 14 says this. Write in slope-intercept form an equation of a line that passes through the given points. So there's some imaginary line that cuts right through these 2 points. Now again, like I mentioned in class, don't get thrown by the instructions that even though when we're all done, they want us to write our answer in slope-intercept form, that's not how we're going to start off. Okay, we're still going to work in point-slope. Alright, but this one isn't as well suited to point-slope as our first one, because what they've given us here is 2 points and no slope. Okay, but we know how to deal with that. Okay, and again, with the method of your choice, the formula, make it a table, or just look right here, find your slope, rise and run. So here, the y-coordinates, the rise from 3 to 7 is 4, so for slope, we have a rise of positive 4, and for the running across, negative 2 to 2, that's also up 4, so positive 4, and 4 divided by 4 is a slope of 1. Now we can do point-slope form. We have a point, and we have a slope. And again, this keeps coming up. We actually have more points than we need, so you pick. Okay, and again, for the benefit of people who want to do it one way or the other, I'm going to do it both ways. You don't have to. I'd be willing to guess that maybe a lot of you might pick this one because there's no negatives, so let's put that work over here. Y minus y1 equals slope times parentheses x minus x1. Alright, so y minus, if we're using this one, the y1 is this number 7, equals the slope, which we found was 1, and then the 2, x minus 2. Okay. All right. Then we put it in slope-intercept form, because what we talked about in class is that if somebody at your table is doing it differently, your 2 answers are not going to match. So in order to make them match, we're going to distribute the 1, which really doesn't do anything, and then we're going to get it in slope-intercept form, which really just means get y by itself. Y equals whatever. So here, the way to get y by itself, add 7, y equals x plus 5. And in fact, this may have been the example we did in class. It's just a coincidence. It also happens to be one of your assignments from the book. Okay, now again, for the benefit of the people that maybe chose this point instead, would look like this. Once again, going to the formula, y minus y1, in this case is the 3, equals our slope of 1, and then x minus x1, which is the negative 2. Okay. We clean this up a little bit, make this 1 times x plus 2, and once again, distributing a 1 doesn't change anything, so we just get x plus 2. We add 3 to both sides, and we get y equals x plus 5. Same answer, whichever way you do it. Okay? And yeah, so I think this does actually end up being the same as the one we did in class. That's just coincidental that the book had the exact same problem. Okay? But that'll at least get you a start. So now on your paper, you've got number 14 done. You've got number 9. Okay, and you can use these as examples just to get you going. I'm hoping that little refresher helps you out a bit. Okay, and if not, ask your classmates, look in your notes, and get this assignment done. All right? Do a good job today. Get this all done. Maybe even try to get to the answer key so you don't have any homework this weekend. And for those of you that we've made arrangements, don't forget I'm out of the classroom, but I'm on campus. So especially those of you that said you'd meet up with me at lunch, don't forget to meet me at the library. All right? All right, good luck, everyone.